Good morning. Today we are going to discuss about waveguide unit 4. So we are going to discuss about general wave behavior along uniform parallel plane. So on completion of this, students will be able to understand what is the meaning of parallel plane and what are the application of parallel plane. So first we will know the basic equation from Maxwell. Consider an electromagnetic wave propagating between a pair of perfectly conducting plane of infinite incident in the plane of y and z direction. See, here we are having two parallel plane. So from the Maxwell's theorem for conducting a rectangular region is given by del cross E is equal to minus j omega mu h. Del cross H is equal to j omega epsilon E. Del square is equal to minus gamma square E, and del square H is equal to gamma square H, where gamma square is equal to minus omega square mu epsilon. For non-conducting media, del square E is equal to minus omega square mu epsilon E, and del square H is equal to minus omega square mu epsilon H. So this can be written as dou square E by dou x square plus dou square E by dou y square plus dou square E by dou z square is equal to minus omega square mu epsilon E. So dou square H by dou x square plus dou square H by dou y square plus dou square H by dou z square is equal to minus omega square mu epsilon H. From the properties of vector algebra, so we know that del cross H is equal to dou by dou x, dou by dou y, dou by dou z, hx, hy, hz. And del cross H, you apply the multiplication rule here, so you will get del cross H is equal to ax dou hz by dou y minus dou hy dou z minus ay dou hz by dou x minus dou hs by dou y plus az dou hy by dou x minus dou h by dou y. From the equation, this can be written as del cross H is equal to j omega epsilon ex ax vector plus ey ay vector plus az vector, and del cross H, similar way the same vector can be used. From the equation, we will have dou hz by dou y minus dou hy by dou z is equal to j omega epsilon ex, and dou hs by dou z minus dou hz by dou j omega epsilon ey, and dou hy by dou x minus dou hz by dou j omega epsilon ez. So we have to find out the value del cross E is equal to ax ay az dou by dou x dou by dou y dou by dou z ex ey ez. So you have to cross multiply this and we have to find out the value of del cross E. Similar way, when we are going to calculate the value of del cross E, you will get the value in terms of hs and ax with the magnitude vector. And we are going to find out the value and equating, you will get dou ez by dou y minus dou ey by dou z is equal to minus j omega epsilon es, dou ex by dou z minus dou ez by dou x minus j omega mu zy, dou ey by dou x minus dou ex by dou y is equal to minus j omega mu z. It is assumed that propagation is in z direction. So the radiation component in this z direction may be expressed in terms of e power minus gamma z, where gamma is the propagation constant. Gamma is equal to alpha plus j beta. If alpha equal to 0, wave propagate without attenuation. So gamma equal to j beta. If gamma is equal to real, then beta is equal to 0. There is no wave propagation. So let hy is equal to hy e power minus gamma z with respect to z. So you will get hy e power minus gamma z into minus gamma. So dou hy by dou z equal to minus gamma hy e power minus gamma z. Dou hy by dou z equal to minus gamma hy. Dou hs by dou z equal to minus gamma hs. Also we will find out the electric field component, we will find out the magnetic field component. So both the electric field and magnetic field in terms of gamma. There is no attenuation in y direction, so y direction may be 0. So you will take the z direction and differentiate with respect to z, find out the value of gamma, again differentiate with respect to z. So you will get both the value in terms of z square. So similarly we will perform the value and we are going to substitute dou square E by dou x square plus dou square E by dou z square is equal to minus gamma mu epsilon E. So if you substituted the value of electric field and magnetic field, you will get the both value in terms of Ex and Ey. And similarly we are going to compute the value of Ez, Ey and Ez. So if you computed both the values, you will get the value in terms of Hx, Hy and Hz. So if you want to compute the value of Hs, Hy, Ex, Ey and Hy. So from this equation, this can be expressed as both the values. So if you want to explain in terms of Hs and Hy, you are going to determine the value of Hs and Hy. So we are going to determine the value in terms of electric field in direction, magnetic field in x direction, magnetic field in y direction, and it is given that omega square mu epsilon plus gamma square is equal to h square. So you find out Hs minus gamma by h square dou Hz by dou x, and Hs is equal to minus gamma by h square dou Hz by dou x. To Hy, gamma Hy is equal to j omega epsilon es, Hy is equal to j omega ex by gamma. So from this value we can calculate the value of most of the electric field component with respect to magnetic field component. So you will get the magnetic field in x direction, magnetic field in y direction, electric field in x direction and electric field in y direction. From this you will find out the value of Ex. Substitute the value of Hy, you will get j omega epsilon Es by gamma. So gamma Ex plus dou Ez by dou x equal to gamma Hy. From this we are going to calculate the value of Ex. So Ex value can be computed minus dou Ez by dou x gamma plus omega square mu epsilon. So Ex is equal to minus dou Ez by dou x gamma square mu epsilon. From that we are going to compute the value of Ex. Similar way the same procedure can be followed for to compute the value of Ey. So both values should be computed. Finally you will get the value in terms of both electric field component and magnetic field component. If Ez, there are three cases. If Ez is present, Hz is equal to, the wave is called transverse magnetic wave. If Ez is equal to, Hz is present and Ez equal to 0, then it is called transverse electric wave or H wave, because electric fields in this propagation. When transverse magnetic wave, the waves that contain neither Ez or nor Ez, both the electric field and magnetic field are transverse in the direction of propagation. So the question will be, what are guided waves? What is TE wave? What is TM waves? Give the Maxwell equation for non-conducting media. What happened for EM waves? Thank you.